essence of calculus is the derivative. The derivative is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to the function at a point. Differentiation is a method used to compute the rate of change of a function fx with respect to its input x. This rate of change is known as the derivative of f with respect to x. The first derivative of a function y equal to fs is denoted dy over dx, where dy denotes a small change in y and dx a small change in x. The process of finding the derivative taking this limit is known as the differentiation from first principles. In practice, it is often not convenient to use this method. The derivative of many functions can be found using standard derivative in conjunction with rules such as chain rule, product rule, and quotient rule.
We choose scuba diving for our group project. Scuba diving. Scuba diving is a mode of underwater diving whereby divers use breathing equipment that is completely independent of a surface air supply and therefore has a limited but variable endurance. The name scuba, an acronym for self-contained underwater breathing apparatus, was coined by Christian J. Lambertson in a patent submitted in 1952. Scuba diving is one of the attractions in the tourism sector. There are many scuba sites in Malaysia, such as Sipadan, Perhentian Island, and Tioman Island. For anyone who wants to try scuba, they need to wear scuba equipment, such as scuba set, mask, and oxygen tank.
What we want to study is about a scuba diving tank oxygen that people always use to go diving into the underwater. The question is, a cylinder diving oxygen tank has a radius of 0.09 meter. If the oxygen decrease at the rate of 0.0147 meter cube per minute, how fast is the oxygen decreasing when the height of the oxygen is 0.66 meter? So, the solution is to find the rate at which the oxygen is decreasing when the height of the oxygen is 0.66 meter, we need to use the related rates formula. Let's denote the height of the oxygen as h and the rate at which the oxygen is decreasing as dh over dt. So given the formula of the chain rule is dh over dt is equal to dh over dv times dv over dt. From the question, we can get some of the information that has given, which is height of the oxygen in the cylinder, that is h equal to 0.66 meter, radius of the cylinder, r is equal to 0.09 meter, rate of decrease in oxygen, which is dv over dt, equal to negative 0.0147 meter cube per minute. We assume it is negative because the oxygen in the tank decreasing. So, what we need to find is dH over dt when h is equal to 0.66 meter. The formula that we can use in this question is chain rule, which represent dH over dt is equal to dH over dv times dv over dt. The volume V of the cylinder can be calculated using the formula for the volume of the cylinder, which is pi r squared h. In the formula volume of cylinder, it has two variables, that is r and h. So we want to substitute one of the variables to be in the other one. The solution is we can substitute r into h variable because in the chain rule, we need dh over dv. So we can express v in terms of h. What we need to do is making a ratio between r and h variable and single the r because we want only h variable in the volume. So r over h equal to 0.09 over 0.06. So we single the r and it will get r equal to 0.09 over 0.66 h. Then after substitute r in term of h, we put the r into the formula of the cylinder volume, which is v equal to pi r squared h. Then we substitute r into the equation, so we can get the value in the term of h only. Then we can simplify the value to be the easiest equation so that we can differentiate it easily. The value is 9 over 484 pi h cube. So we can differentiate it so that it will be dv over dh equal to 27 over 484 pi h squared. After that, we can put all the value that we have in the chain rule formula. dh over dt equal to 1 over 27 pi h squared over 484 times negative 0.0147. Then we can get negative 0.0147 over 27 pi h cube over 484. So the answer we get is in the term of h. If we want the exact value, we can enter the value of h, which is 0.66. So the answer we can get is negative 0.1926 meter per minute. Therefore, when the height of the oxygen is 0.66 meter, the oxygen is decreasing at a rate of approximate negative 0.1926 meter per minute. That will be the final answer for this question.
In daily life, derivatives are frequently employed to measure how much something is changing. It is intriguing from a mathematical standpoint since their real strength lies in how they are applied to issues in the real world. Derivatives are employed in various fields, but some of the most significant ones are mathematical physics, biology, and economics. This tool has a wide range of practical application outside of math difficulties. Nothing in our world is worthless. When we claim something can be used, what we really mean is that we don't know how to use it. Anyone who understands its value won't be able to quit thinking about it. Any profession can benefit greatly from knowing how to use derivatives, when to employ them, and how to put them to use in daily life. Seems like we have reached at the end of the video. I would like to thank you for spending your time by watching our video presentation. We hope that this video will expand your knowledge and help you to implement the application of derivatives in real life. Bye bye.